Oh, good morning, everybody. Thank you very much for joining me today, where we're going to look at lesson 5. And lesson 5 is a pretty tricky little assignment, and I would say one of the more important assignments with site observation and site analysis, and that is to be able to basically read how water is going to affect your project site, and not only the water on the site itself, but perhaps from sites around your location and how that might influence your design. So we're going to take a little bit of a look here. I'm just going to share my screen. There we go. Not the right. Let's see here. Let's go to lesson 5. Okay. So yeah, lesson 5 is an exciting one. That's certainly a layer that I really enjoy working on with our design work, and that water is definitely one of the big factors in the landscape and really does drive what you can do within it. But let's take a look at the assignment, and we are also going to look at any questions that come up here. So I would encourage everybody that if you do have questions today, what I was hoping to start doing is putting all the questions and answers within the Google Doc here. And that way, when we get to the end of the course, you're going to have yet another resource here that you can reflect back on if you wish. So we're going to try and do that today. I noticed that Javan Bernakovic, one of our other instructors here, has been following this format, and I think that has a lot of value, just in terms of a resource, again, that you can pull on at any time. So let's take a look at lesson 5. And you can see there's 3 different parts to that. We have the water survey, which is, pretty pretty mild in terms of the amount of work you need to put into this. It's just asking where your water comes from, where your wastewater goes, as well as some interesting notes. What's the record 24-hour rain event and the average annual rainfall, and how, questions to ask yourself. How is your site going to be impacted by a major event, and why? And also roofing materials. So that's always an important component when we get to rainwater harvesting, is what kind of a surface we're collecting off of, which does play into what we can do with that water when we go to reuse it. So again, the water survey, pretty straightforward. It's only worth for 4 points. And then we get into the thick of it, where we're looking at our watershed maps. So let us just go to the template file here. We'll get ourselves into the water survey. And again, that's pretty straightforward. Adding images here is always a nice idea, makes the report or the assignment a little bit richer in terms of the content. But really, where I think quite a bit of the work might start for most folks is when we get into watershed mapping. So this is the first part of this assignment is something that I would recommend really dialing into and trying to get a good grasp of this. And this is going to play into further parts of the assignment, and that is your micro watershed practice sheet. So we're looking at 2 different types of watersheds in this assignment. The first is the macro. And that can be, I'll just show you watershed from where I live. And we'll see if we get what I'm looking for here. I just want to show you. Oh, I'll have to be a little more specific. That is really odd. I have, that's no big deal. I have this on a document that I've got up. So let me just switch to that briefly. All right. Now I'm not sure why I couldn't find that. This is a design that we just submitted the other day to a client. And here is a macro watershed map of Vancouver Island. And Vancouver Island's pretty large. And you can see how these macro watersheds are themselves very large, and they cover quite a big area, and they're quite easy to locate on the web. So if we go back to what we were looking at prior, there we go. We're not going to look at that. I'm going to go back to, okay, we'll go there. So that is the first part of the assignment, is the macro watershed, and this should be pretty easy to locate. And then adding some graphics to it is a good idea. So we want to see the boundary, the basin, which is all areas within the boundary, how water flow might flow in that, and where your design site is. That's an important part of that. And of course, then we have the micro watershed, which relates to this little practice sheet that's at the beginning. So what do we do here? Well, if we back up a little bit, so I'm going to zoom out. You can see that we have a couple tutorials up here. And I would recommend you take a look at those. There's also a video here you can look at. There, if we go up to the discussion board itself, we should have something in the resources here. So this is very helpful. It's graphically how we would take a look at this micro watershed, and that's what we're looking at here. We have our project site, and we have lands around it that can flow with, can run off into the project site itself. And then again, there's some more video tutorials here. So I would highly recommend that you really check those out. So when we look at the practice sheet, what we're trying to do, is we need a contour map. So if you have let's say you have your project site, but you don't have a contour map, I would suggest you go to Contour Creator and use this interface here. I will just, you obviously put your location in here. You can change your resolution. I will just zoom in on a location. Okay, let's say this was my project site, and I wanted to figure out the micro watershed. So in an urban setting, we have roads that are constraints, okay? And so we know in 99% of the cases that any water flowing from the other side of the road is unlikely to jump over the road and get into this, well, get closer to the project site, get within this potential micro watershed basin. So if this was my project site here, what I would do down on the menu here is I want to have intervals, my contour intervals. I'm going to put them in feet, and I'm going to make them 1 foot contours, 1 foot contours, or 1 foot intervals. And then what we have to do is we have to click in the top left and top right of the area that we want information in, and you can move these around. But in an urban site, I would go just, follow the block basically, and then hit this button here, get data. And this is going to show us a legend on the right, and the contours are shown here. So you can see the ground is elevated in this direction, but everything outside of the road, beyond the road, we're not going to really be too concerned with. Let's see. No, it's not going to do that. There we go. So I know that where we are, I think that's our project location there, somewhere in here. So we can see it's low here and higher here. Let me just get one of my little tools. There we go. Now I'm going to just share my entire screen here because I don't think you'll see it otherwise. There we go. All right, so we will get on. Okay, yeah, we're erasing. Just getting rid of the previous line I had drawn. All right. So if this was our, well, we'll say it doesn't really matter. We'll say this is our project. Well, that's a bit of a thick line. That's our project site here. Just going to make it a different color. So if we're trying to locate our micro watershed within this block here, we do know, and you will find out going through all the content there, that what we want to do is, again, locate any lands that are above our project site that potentially could overflow could go into the project site, so it could influence it. Now, how do we determine that? We know that water will run right angles to contour. So if we have a contour line here, and this is higher than this, we know that the water is going to flow in that direction. Over here, it would flow in that direction. So it's always going to be right angle to the contour, and that lets us calculate our micro watershed quite easily. There we go. So if what we traditionally will do when we start, and it's very similar to the micro watershed exercise sheet, is we'll start at the bottom or the low point in the project site, and we will start to calculate where our water is going to come. So you can see the way these lines are going, that if a drop of water hits here, it's going to run right angle to that contour and clip the corner. Sorry about that. All right. There we go. All right. So we will just work our way up here. And then you can see it changes angle a little bit. And then it's going to change angle again. And we basically end up, somewhere over here. Okay, so if we start on the other corner, that's the lowest point in our project site. We can do the same thing. And this is not exact. I'm not being, completely precise with this. If I was doing this for the assignment, I probably would, but we're just making sure that this direction of flow is 90 degrees to the contour as it's going downhill. So I'm going uphill, so I kind of have to keep that in mind as I'm going up. And this looks like a bit of a tricky area there. So we've done both sides, and then we can actually just join these. Okay, so that would be my micro watershed basin and micro watershed boundary. So if any rain falls within this area, it could potentially run off and influence the project site here. So I'm just going to flip out of that and back to that itself. All right. Oops. There we go. So if we're looking at the practice sheet, we can see that the project site is located here, and these are all clearly labeled. So this would be the low edge of the project site, and this is where we're going to start calculating our micro watershed. So I'm not going to show you where that is, but I would recommend that you give this some practice. And you will discover that this project site's actually in a valley here. So it will receive potentially quite a bit of water. And that part of the assignment, this whole micro watershed component is a really big piece. So this is a valuable tool that you can take with you with all your design work and figure out what it's in some ways it's almost like your sector map. With the micro watershed, we're looking at all of the areas outside of the project site that could potentially be influenced with runoff. So if we go back to this project site or this exercise sheet, and we end up calculating once you've run through this practice sheet, you'll be quite shocked at the size of the micro watershed that could influence the site. So if you're designing and right out of the gate you realize, there's this potential huge volume of water coming straight at your project site, that's really going to help you go through the design process, knowing you have to put something in place to alleviate that potential flood or surge of water, and hopefully turn that potential liability into an asset. So that is a big part of this assignment, is that micro watershed. And again, the practice sheet is a great idea, and there's some basic instructions there. And then once you get through the macro and the micro watershed, then we're going to go and we're going to get really specific to your site and that site water flow analysis. Okay, so when we're looking at the site water flow analysis, there's a number of things we want to do there, and of course having your base map and then all of these other items included with your base map. So the roof areas, any potential gray water, locations where you have taps or spigots, and any other impermeable surfaces, and that could be a driveway, it could be a walkway, a patio area. It can have a lot of different appearances. Gravel driveways are compacted and they will shed water, so you want to include that. And really, contour lines are an important part of this. So you would have had that in order to do your micro watershed map. So try and carry that through at least in a, partially. And when I say partially, I've been just including several contour lines and label those so we know what the direction of the flow is. And then we have some charts here that we want you to look at and some calculations. So if we look back at the assignment itself, you can see we're going to put your map here and indicate these roof areas and other impermeable surfaces. And then we're going to bring all this information over, your total site, how large that is, the annual rainfall, and then there's a formula here to calculate the potential runoff. And then we're going to look at that 24-hour rain event and see what that generates. And then we're going to bring in your impervious surfaces here, and you can fill those out either in metric or imperial. I would imagine whatever your unit you're working with previously here, if you're square feet, then you're going to want to stick with imperial, even though metric's a lot easier to calculate. Just remember with imperial that it's, the area times the depth, and you also have to add in this little conversion factor of multiply by 7.48 in order to convert that into gallons. So that's an important part to include. Yeah, so this is a very handy little bit of info. And then we go to this extra water flow credit. And just to give you a little bit of a heads up, this is all about the micro watershed. So once you've calculated that, you can drop in a map showing that. And just be mindful, again, if you're in a urban area, that the roadways are going to be constraints. And if you are in a more of an rural situation, just trying to find something that might be appropriate there. Like this property here, I know it's about 25 acres right here. That's going to be quite different. You are going to be, you have a roadway here definitely to factor in, and one here. But I know with this property, the slope's going up. So in all likelihood, the micro watershed's actually going to come all the way up to this road here. So this would be quite large. And I do know this property, and it gets a lot of water flowing through it. So again, when you're on acreage, look a bit beyond, but do factor in, again, the roads. That is a big part of the micro watershed calculation, being a constraint there. And yeah, so that is a site water flow analysis. And again, that's a little tip for the extra credit there. Then we have a SWOT analysis. So a few ideas might pop out just based on the exercise you've just gone through. What are some of the strengths? So it may be, you have a lot of impervious surface you can collect from. So you have a lot of potential to store water. You may be in a situation where you are at the top of a watershed. So I think I might have an example, one of the student examples that is found in the module section. Now, this may not be a perfect micro watershed example, but you can see that the student indicates they are at the top. of a hill, and there's no other significant flows coming into the property, even though they are showing a little bit here. So that may be your situation. You may not have any water flowing onto your project site from another area. Where are we here? This is a micro watershed from another example. This is contour information. Now, the one thing that we don't know here is any of the values with these contours. We can assume, given the flow arrows that we're climbing here, this is the project site. There we go. Yeah, this is the project site boundary. And then this dotted line is what the student figured out is that micro watershed. So if we zoom in here a little bit, we can see that that student's calculated based on right angle to contour, and that looks pretty accurate. And again, even on, I think this is a 2 or 3 acre site, but even with that, we have the roads as a constraint here. So that's something to keep in the back of your mind. This would not go beyond. Okay. So yeah, that is pretty much what is going on with lesson number 5. So there's a lot to it, and we do have quite a few resources built in here. And you can tell by the rubric that, sorry, we haven't looked at the rubric, but just for the points assigned for each part of the assignment, you know, this the second half there, or you know, part 2 and 3 are really where you're going to want to place most of your energy. And then we get into the rubric, which is always really good to look at and make sure that you have included all of the items that are listed here, because this is what I use as a guide when providing grading. Okay. And let's just go see if we have any questions at all. Right on, we do, from Anna Karen. So let's take a look at that. And I just noticed the chat here, sorry, it's from Stephanie. So let's take a look at the chat first. How's that? So Stephanie says that she's had no success getting topo lines. Yeah, try Contour Creator. Okay, and I kind of ran through a brief tutorial on that, so check that out, Stephanie. And I don't know if you have. I don't use contourmaps.com, so do try Contour Map Creator. And you know, the caveat here is, you know, I would never use either of those for professional use. They're just not accurate enough. But for this exercise, it's a great option. We don't have to be, you know, deadly accurate, but it does give you the opportunity to learn, you know, how to forecast water flows. So
this is Stephanie. Can you hear me?
Oh yeah, hi Stephanie.
Yeah, hi. So I am on contourmap creator.com, and
okay,
is that the one you were indicating?
No, it's this is contour map creator.urgr8.ch. That is the, if we go back to the Google search, just searching contour creator, that's what you'd want to go after, rather than the contour map creator that's
Okay.
below.
All right.
And, you know, they're probably using the similar data, but let's just take a look at your address and we'll see what I come up with.
Okay. You did demonstrate it in my feedback, and so maybe I was just simply on the wrong in the wrong place.
Yeah, well, that could well be. Let's just I put in the wrong. I thought I'd be smart and copy and paste here. It did not quite work. So we'll just see what we come up with. That looks like it's getting close. Now, the only thing I don't like about this is I have to search for the site. It doesn't put a little pin on there for me.
Hmm.
Let's see where you are. Does this look familiar to you?
Yes.
Okay, so I'm just looking for.
And I'm following along in my own contour map creator.urgr8.ch.
There you
So
go.
yes.
You should be in the middle here somewhere, but I don't see.
It
Oh,
is right
Caroline.
in the
Okay,
middle.
there we
Yeah.
go. I was looking for a different. Now I remember. So what I would do now um, is there's a number of different ways you can show the information, but what I like to do is put it on level interval, and then I'll put it on uh, imperial units. And you can start with 1 foot contours. And if you get, if it's too busy, you can change that and back it off a little bit. But once you've kind of set this up, you can click in opposing corners, and then let's just for interest's sake, let's get the whole block, and then you have to hit get data. And that looks like it's a little bit on the busy side.
It actually worked. So
Aha.
I think I was just in the wrong
Yeah. Okay.
space. But yeah, it is very busy. I guess.
It is. So so what I did was I just changed it to 2 foot, and then you'll want to zoom in a little bit. And probably the easiest thing here is grabbing a screenshot of
Mhm.
this. But you can tell you've got a little high point here that flows in this direction, and there's a high point here, but it looks like water that would land here would head in this direction
Right.
and away from you. So I believe it's these 2 lots that your project site is, if
They're
I'm not
actually
mistaken.
further to the left, the two that almost you're almost
Okay,
there. Yeah,
these
no,
two.
not no, even further.
Oh, okay.
Yeah, that one
Oh,
and
over
that one.
here.
Yeah, over there.
Okay. Well, that's interesting. So you have an elevated area here and here,
Right.
and you can see if water did land on this part of your neighbor's site, that it potentially could fall down this slope and head towards your project site. And that makes sense given what I recall from your
Right.
project site needing retaining or there being some slope here.
There's a big slope, and the client actually owns the house up above, but
Oh,
it is not part of the project site, but probably should
right.
be.
Okay. Well, yeah, it's definitely there's the 1 foot contours, but that makes it a little tricky. So I think 2 might be best. Yeah, this would be the absolute high point, and your micro watershed isn't going to be huge,
Right.
but it is good to note that, especially when we're dealing with steep slope, if you're going to have water rilling down here, that's really good to know ahead of time.
Right.
And then you have an alleyway here, not really a road, so we could almost ignore that as a road. So, um,
Right, that's
Yeah.
gravel, and it's between the two properties that
Mm-hmm.
are part of the project. So it's
Right.
part of, yeah.
Okay.
So very helpful. Thank you.
Yeah, no problem. So if you want, you just get to this point and take a screenshot,
Okay,
and then you can do a little bit of graphical work on top of that.
right. I like that it
Yeah.
has the water treatment plant in that screenshot right
Oh, there
there.
you go.
Yep,
Yeah. Okay. Well, I'm
right.
glad that helps
Thank
you out
you.
there. Now, we did have a question on our Q&A document here. Let's take a look at that. So it's Anna Karen. So it's all about wastewater septic. Okay, she would like me to talk about how septic system affect the landscape, most effective, important aspects we should take into consideration. Um, that's a good question, Anna Karen. Are you referring to how one septic field might influence the project site? And you can unmute if you wish, if you're available to chat.
Can you hear me?
Yeah.
Hi. So we have a septic tank, a septic system here in our sites, and
Yeah. Yeah.
it's mainly just the lawn. So I was wondering if how I don't know how to. I'm really bad at asking questions. So how does it affect the design, the landscape, if we, for example, wanted to plant a tree? I mean, I know we can't I or
Yeah,
or sorry, I have my partner here with me too.
Mhm. Yeah.
yeah, and so or if we want to make swales or store water on the wrong way from the septic tank or the septic drain.
Right. Well, it's a good question. Yeah, we have a septic system on our property, and you definitely want to have a few considerations with those. So the main thing is septic systems rely on evaporation to operate properly. So you want to have some sort of vegetative cover on the field, and most often that's, perennial grasses, right? And I'm sure that's what you currently have. You don't, there are instances that I've seen where people have to drain around their septic field. So they might have water coming towards it and they don't want that to influence it. But more often than not, people will have their fields located in a really good location that has high perk. So the water not only perks really well, but it's also going to evaporate. I think about 40% of the water evaporates. It's either 40 or 60. It's quite a high number. And you don't want any large, you don't want it close to any trees, anything that can access the piping with root systems. And then you'd also want to be a little bit mindful of what you grow on top of it. You wouldn't necessarily want to put your annual vegetables right on top of that, okay? Because they will tend to pull up. If there were any pathogens, they would end up in the tissue of the annual vegetables, whereas woody plants or perennial plants are kind of safeguarded. Let's say I had raspberries near, well, for instance, we have a plum tree that's near our septic field, it's not on the field. So we're not too worried about that because any pathogens will end up in the wood of the plant, not in the fruit itself. Does that kind of cover what you were looking for, Anna Karen? I'm not sure or if you're perhaps wanting to consider the effluent itself in a septic field and how that affects the landscape. I'm not sure I've answered your question in its entirety, but
No, yeah, it's a very good info. Thank you very much.
Yeah, no problem. So yes, it is definitely something you want to dial into and make sure you're not jeopardizing. I know where I live, a septic system is pretty expensive. Um, and just an interesting note that our septic field's 40 years old. It's as old as our house, and eventually they fail. Ours is a gravity system, so there's no pumps or there's no treatment plant, nothing like that. But we are going to start utilizing a composting toilet system next year as a trial to try and alleviate some of the pressure on our septic system, plus generate our own compost out of that. So that's a whole other kettle of fish. And if you are at all interested in it, let me just see if I can find a friend of mine's book. Trying to remember the exact title of it. Oops, I'll have to look at images here. Yeah, it's a great, there it is, the Essential Composting Toilet Book. Now, funny enough, just finished up a course that was online on that. It's right here. And if you haven't heard of it, regenerativliving.online is a online regenerative education platform that one of our instructors, Javin Bernakovich, has put on, or he's set this up over the last few years, and they have some amazing courses here. So I've taken a few courses already. There's one coming up on coppicing I'm taking. I've taken the composting toilet, done a hedgerow course. So, and as you can see, they have, my wife took a family food security course. Another instructor, Neil Petrando, has done a low-tech erosion control course. You know, it's a really, really interesting website that if you're after some additional information when you finish up this course, there's a lot of good resources out there to dial into. So let's see here. Does anybody have any other questions? We've got a few minutes remaining. Actually, what I'll do, I'll wait to hear from anybody on the call here if they do have a question. If you do, please just unmute yourself and fire away. Doesn't look like we're getting that. Maybe what I'll do, I'll just show you a water layer that we just presented on Saturday. Again, that was the macro watershed map, and here is a micro watershed map that we did. Let me see here. So this is about a 8-acre project site, and we have some really good contour information that's not shown in its entirety because it was LiDAR mapping, and this was the edge of the map that was available for us. But this is basically the micro watershed. So there's a road that runs up here and a road that's running here and then a road that runs up here. So even with acreage, you know, the road is basically the constraint. And this is basically how that micro watershed ended up. So there's 25 acres in total, and that includes the project site. So if we took that away, we're looking at more like 17 acres that could potentially drain into this area. And as you can see here, there's actually quite a drainage channel that runs right through the property. So where our clients live, they have, oh, I'm trying to remember their exact annual rainfall. I believe it's up and around 1900 millimeters. So it's almost 6 feet per year. It's huge. And this is their annual potential catchment, over 51 million gallons. So it's quite startling. And fortunately for them, this drainage channel is safeguarding their homes, and there's basically no risk of flood for them, but we do want to try and capture as much of that and slow it down. So that's again what we've done. And if you go through each one of these lines that are between the contours, they're basically looking, you're basically going at a right angle of contour as you're going down in slope. All right. That gives you a little bit of a heads up there. Yeah, so I'm not sure if anybody has any questions related to lesson 5 or anything else they want to talk about. We have another 10 minutes, entirely up to you. If not, we'll call it an early day. I'm just gonna have to let my, here we go. Somebody else picked that up. Sorry. Let me just see if we can look at anything else today. Oh yeah, so we're gonna have the lesson 5 assignments due next Monday. And then at the end of the week, we then have a little bit of a break through December, and we'll be starting up again in January. So for those that may feel they've fallen behind a little bit, this is a good opportunity to catch up with any work that you feel you got to get caught up with. Also a good time to rest over the Christmas season. And then we're all ready to go when we hit January. And trying to remember the exact date. Let's see here. Just looking at the exact date that we'll be coming back. We'll be starting with a Q&A video. So it's due on the 16th. So the week before we'll be having a Q&A meeting. And yeah, so that works out really well. It gives you a nice break. So there's a few weeks there. So yeah, so if there's no other questions for today, I will just go ahead and we'll call it a day, and we'll look forward to seeing your assignments next Monday. So thank you very much, everybody, for attending today's Q&A, and look forward to seeing everybody's assignment.